So what we've seen with all of our graphs so far is we use the axes family to help us draw our graphs. Now the tan graph is a little bit trickier with the axes family because 2 places, pi over 2 and 3 pi over 2, is not possible. That shows up on the graph as an asymptote. And at 0 and pi and 2 pi, it's equal to 0. Now, you could label another point on here. You know that when the angle is pi over 4, tan of pi over 4 is 1. And so you could label points where things are 1 and where things are negative 1. And you would be able to see why the graph goes like this. It needs to go through those points where it's 1 and negative 1. It needs to go towards the asymptotes. And so we get a shape of a tan graph, almost reminds us of an x cubed graph, but it's different because it goes towards an asymptote. So we're going to need to know all of these graphs, the cos graph, the sine graph, and the tan graph. And again, notice that we use the axes family as the key points from your pi plate. And we're going to move forward and we're going to find out if we added all the transformations. Remember, multiplying in front, vertical stretch. Multiplying inside, horizontal stretch, reflection, or compression. Inside horizontal translation, notice it's in factored form. And then finally, vertical translations up and down. And we're going to develop a shortcut for this by noticing a pattern based on the characteristics of our sine and cosine graphs. So we'll go to example 1. And in example 1, we're going to be looking at the a values. So if you had a 2/3 out in front, using our transformations unit, we'd say that's a vertical compression. You're going to multiply all of your y values by 2/3. And so in your head, you would have your axes family. And in your head, you would think of your regular sine graph. And a sine graph starts at 0, then goes to a maximum, back to 0, down to a minimum, back to 0. Here's your regular sine graph. Now, we are going to do a vertical compression by a factor of 2/3, which means we multiply all of our y values by 2/3. Can you see that all the places where it's 0 are going to stay the same? Can you see your x values won't change? So I'm going to label my axes family again, because I'm only changing y values. But instead of going up to 1, because I'm multiplying y by 2/3, does it make sense that it changes up to 2/3? And instead of negative 1, negative 2/3. Still starts in the middle, then goes to maximum, to middle, to minimum, to max, to middle, sorry. And we notice that our amplitude,
Thank you, sir.
you're welcome, is now 2/3. So your amplitude is the measurement from a maximum to the center line or from a minimum to a center line. That distance is your amplitude. And it just so happens that whatever is your vertical stretch will always end up being your amplitude. So when we were looking at, when I wrote this out before, and this is for sine or cosine, whatever is your vertical stretch, whatever is your a value, is going to affect your amplitude. And there's got to be some way you can memorize. You have to figure out a way that you're going to be able to memorize that your A value affects your amplitude. There is some sort of strategy you can come up with that you can remember that your A value affects your amplitude. That would be wonderful. However you come up with it, that would be great. So, what we're going to be able to do as a shortcut is instead of having, you know how we used to do all the points? And for a sine and cosine graph, there's like 5 points. You'd have to write out all 5 points. Do the arrows. Say y by 2/3 to all 5 points and then draw them. Now we have a shortcut. The shortcut we can do is we can just quickly say, I'm going to label my amplitude as 2/3. So go up 2/3 from my middle, down 2/3 from my middle. And now I can graph it quickly because a sine graph starts in the middle, goes up, then back to the middle, down, back to the middle again. So when we get to B, -4 cos. We would recognize that the negative is a vertical reflection, the 4 is a vertical stretch, and you would need to multiply your y values by -4. So in your head, you would say, I know what my regular cos graph looks like. I'll draw my axes family. And go up to 1 and down to -1. This is my regular cos graph. Regular cos graph started at 1, starts at a maximum, then center line, then minimum, then center line, then maximum. So you'll hear me talk a lot like this as well as a shortcut for drawing sine and cosine. Sine starts on the middle going up, and the cosine graph always starts at a maximum. So there's my cosine graph, and now with the shortcut, my A value is -4. So my amplitude will be 4. When we talk about amplitude, we never say amplitude is a negative number, because it's a distance. It's a distance from the center line to the maximum. So having a -4 out in front will still mean our amplitude is 4. So I'm going to draw a new graph. I'm going to go 1, 2, 3, 4 up, and 1, 2, 3, 4 down. And since only my y values are changing, my x values won't change, so I can still label my axes family. And a cosine graph normally starts at a maximum. Where do you think a negative cosine graph will start if there's been a vertical reflection? It's going to start at the minimum. So if normally a cos graph starts at a maximum, a negative cosine graph is going to start at the minimum. So I'm going to start at -4. Then I'm going to go to center line, then maximum, then center line, then minimum. And the amplitude, which is the distance, is now 4. So we find out that our A value, as a shortcut, affects our amplitude. And if you can have some way to remember that, then that's going to be helpful. Okay, questions for practice on this one are 3A and B, 4, 5, and 9.